Hey guys, Ms. Fearing here. Welcome to Unit 2 Notes 4, Solving Systems Using Substitution. So today's learning target is I can solve systems using substitution. So we have 4 steps that go into solving systems by substitution. Step 1, we want to solve one of the equations for one of the variables. So that means that we either want an x equals or a y equals happening. Step 2 then is we substitute that expression into the other equation. Step 3, solve for the remaining variable. And then step 4 is substitute that value into either equation and solve for the opposite remaining variable. So I know those steps seem like a lot of words and you're not quite sure what they mean. So hang in there. When we get to an example, it'll all start to make some sense. Here's 2 special cases that we want to keep in mind. If both variables cancel out and what is left is true, we say that this system has infinitely many solutions. So if you end up with something like 3 equals 3 or 0 equals 0, then we would write infinitely many solutions, or if you remember, we can write that as IMS. If both variables cancel and what is left is false, then we say it has no solutions. So if you end up with 3 equals 5 or 2 equals 0, we know that those things are false. They don't equal each other. So then we would write no solutions. So let's look at the first example here. Step 1 says we want to solve one equation for one of the variables. Well, we already have an x equals here, so this is good. We don't need to solve anything. So now we're just going to go into step 2 of substituting that expression into the other equation. So we know that y equals this, x equals this. So this whole thing is actually going to go in place for that x variable up there. So instead of writing x, we're going to write 2y plus 36. And then I have to finish writing the rest of the equation. So I still have plus 2y equals 8. From here, I'm going to go ahead and I'm going to solve. So I'm going to combine my like terms. So I get 4y plus 36 equals 8. And we're just going to solve for y. So subtract 36. So I get 4y equals negative 28. Divide by 4. So I'm left with y is going to equal negative 7. From here, this is my step 4 then, where I'm substituting the y back in to one of the normal equations, or the first original equations. So I'm going to actually use the second one with the x equals because it's going to be a little easier for me. It's already set up. So I'm going to get x equals negative 14 plus 36. So x is going to equal 22. So my final solution is going to be 22, negative 7. So now look at example number 2. We want one of these to be an x equals or a y equals. We don't have that yet, but we can do that. This bottom equation seems like it'd be pretty easy to solve for x. We just got to subtract the 2y, subtract the 2y. So I'm going to get x equals negative 2y plus 15. So now I'm going to take this and I'm going to plug it into the top equation I haven't touched yet for the x value. So I get 2 times negative 2y plus 15 minus 3y equals 2. So we need to distribute first, so negative 4y plus 30 minus 3y equals 2. Now we're just going to combine our like terms. So negative 7y plus 30 equals 2. Subtract 30. So negative 7y equals negative 28. So y is going to equal 4. So now we're going to go back into that equation. The x plus 2y equals 15, and I'm going to plug the 4 in for the y. So I get x plus 8 equals 15. So I know that x has to equal 7. So my final solution is going to be 7, 4. So number 3 is similar to number 2 that we just did. So I want you to pause the video, try the problem on your own, and then come back and check your work. So I ended up with the solution -3, -1. If you get something different, go ahead again, pause the video, come talk to me, check in with a friend, make sure that you really understand how to do this before moving forward. So number 4 here, we have 2 equations that are in y equals, so we can jump right into substituting in. So I know that y equals this thing, so this is going to go in place for the y on the first equation. So I get y plus x is going to equal 3x minus 4. From here, we're just going to solve for x. So we need to get our x's on one side and our numbers on the other. I'm going to subtract x first. So I'm going to get 4 equals 2x minus 4. Get all your constants to the other side. And then divide by your coefficient. So I get x equals 4. So now I'm going to go ahead and plug that in for one of the original equations. So y equals 3 times 4 minus 4. So y is going to equal 8. So my final solution is going to be 4, 8. So now let's go ahead and look at 5 here. Neither one of these equations are solved for an x or a y, so we're going to have to do that ourselves. So the bottom equation looks like it's going to be a little easy to solve for x. I just have to divide everything by 2 to get rid of that. So I'm going to have x equals 2y plus 2. So now I can take what x equals and I'm going to plug it in for x in the top equation. So I get 3 times 2y plus 2 minus 6y is going to equal 6. Distribute first, so 6y plus 6 minus 6y equals 6. So my 6y cancels out with my negative 6y, so I end up with 6 equals 6. This is a true statement. Remember, if it's a true statement, we write infinitely many solutions, or IMS. Looking at example number 6, same kind of idea. We need to solve one of these for x or one of these for y. So I'm going to go ahead and solve this top equation up here for y. So I need to subtract 7 from both sides. So I get y equals 2x minus 7. And I'm going to take that and now I'm going to plug in for the bottom equation for the y value. So I have 6x minus 3 times 2x minus 7 equals 24. Distribute. So 6x minus 6x plus 21 equals 24. Well, the 6x minus 6x cancel, and I'm left with 21 equals 24. This is a false statement. We know that 21 does not equal 24. So then this is going to be a no solution. So now let's look at example number 7. We have Campus Rentals, who rents 2-bedroom and 3-bedroom apartments for $700 and $900 per month respectively. Last month they had 6 vacant apartments and reported $4,600 in lost rent. How many 2-bedroom and 3-bedroom apartments were vacant? So we have 2 things we're talking about. We have our 2 bedrooms, which I'm going to call my x's. So my x is going to be my 2-bedroom, and my y then is going to be my 3-bedroom. So anytime I'm talking about the 2 bedrooms, I need an x with it, and anytime I'm talking about the 3 bedrooms, I need a y with it. So now I'm talking about money. I got a money situation, and then just there's the number of apartments available. So when I have $700 for my 2-bedroom plus $900 for my 3-bedroom, I need that to equal the $4,600 that I have lost in rent last month for those vacant apartments. So now that I've used those numbers, I'm not going to use them again, but I need to write an equation that shows I had 6 vacant apartments. So when I take my 2-bedroom and I add my 3-bedroom to it, I need that to equal the 6 that I had empty. So now for substitution, we need to solve one of these for our variable, x or y. I'm going to solve the second equation for x by subtracting y from both sides. So I'm going to get x equals 6 minus y. And I'm going to take that and I'm going to plug that in for the y value up there. So I have 700, sorry, not plugging that in for the y value, I'm plugging that in for the x value, because that is what we solved for. We solved for x. So this is actually going to go in for the x value. So I'm going to have 700 times 6 minus y plus 900y equal to 4,600. I'm going to distribute and then solve for y. So 700 times 6 gives me 4,200 minus 700y plus 900y equals 4,600. Combine my like terms. And then I need to subtract that number. So I get 200y is going to equal 400. So y is going to equal 2. So right now I know that I have 2 3-bedrooms. So I'm going to have 2 3-bedrooms. Now I'm going to take that, I'm going to plug it back into one of the original equations. So I had x plus y equals 6 in the beginning. So I know that y is 2. So x plus 2 has to equal 6. So I know that x is going to equal 4, which means I'm going to have 4 2-bedrooms then. So example number 8. The larger of two numbers is 8 more than 4 times the smaller. If the larger is increased by 4 times the smaller, the result is 40. Find the numbers. So we have 2 things we're looking for. We are looking for a smaller number and a larger number. So anytime I talk about a smaller number, I'm going to write x, and anytime I talk about the larger number, I'm going to write y. So the larger of two numbers, y, is really important. It always tells me equals. 8 more than tells me to add 4 times the smaller. So that's my first equation. Second equation, if the larger is increased, so the larger plus, because I'm increasing, 4 times the smaller, the result is 40. So I already have one of these in a y equals, so I'm going to take this and plug it in for the y value. So I'm going to end up with 8 plus 4x plus 4x equals 40. And now we're just going to solve for x. So 4x and 4x gives me 8x. Subtract 8. So 8x equals 32. Divide by 8. X is going to equal 4. So I can take that and I can plug it back into one of the original equations again. So y equals 8 plus 4 times 4. 8 plus 16 is going to give me a y equal to 24. So my solution is going to go ahead and be 424. But remember, we need to write it in words. So the smaller number is 4. And the larger number is 24. So now we're on to our last word problem. I want you to go ahead and try this one on your own and then come back and check your work. So I found out that the senior tickets cost $4 and the child tickets cost $7. If you had any questions on this one at all, please pause the video, come and talk to me before starting the assignment. You could have went about using the elimination to solve this if you remember that from before your last quiz, and it probably would have been a little bit easier for you, but there are multiple ways to get to that same answer. Go ahead and start that assignment. Make sure you talk to me if you have any questions at all.